Alright, Chapter 7, Reinforcing Steel. As a steel worker, you must be able to cut, bend, place the reinforced steel with a trap to discover the purpose of reinforcing steel with concrete, instruction type of the shape of the reinforcing steel, common use of the techniques, tools, use of the steel worker, and rebar. Reinforcing steel work. This chapter begins with a presentation of fundamental information concrete to help you understand how the rebar work fully. Reinforced concrete. A steel worker will probably concern with the reinforced steel placement, but you should be somewhat concerned with the creating concrete as well. Concrete with the reinforced steel added becomes reinforced concrete. Structures built on reinforced concrete, such as retaining walls, building bridges, highways, surface development, or other structures, are referred to as reinforced construction. Concrete structures or reinforced concrete construction. Concrete materials. Concrete is a synthetic construction material made for the mixing cement, fine aggregated, usually sand, coarse aggregated, usually gravel, crushed stone, water in proper proportions. Mixture hardens rock-like mass as a result of the chemical reaction between the cement and water. Concrete will continue to harden and gain strength as long as it will keep moist and warm. These conditions allow the chemical reaction to continue. The process known as curing. Durable, strong, burnt concrete is made by correct proportion, mixing the various materials with the proper cutting after the concrete is placed. Correct proportioning of the concrete ingredients is often referred to as the mix. The quality of the concrete is largely determined by the quality of the cement, water, paste, the ponds, aggregates to give it the strength of the concrete will reduce if the paste has water added to it. The proportion of the water to cement is referred to as water-cement ratio. Water-cement ratio, the number of the gallons of the water per cement, pounds per cement. High-quality concrete produce usually lowest water cement mixture possible without sacrificing workability. Or because concrete is plastic, when it is placed, forms of the built-in contain form of concrete until the hardened short forms of formwork are discovered. The roll of the whole freshly placed concrete, the desired shape until the hardens all ingredients to mixer placed with the concrete mixer. After through mixing, concrete is transferred by numerous methods, such as by bucket, by wheelbarrow, and so forth, of formwork in which reinforcing steel has been placed. Concrete reaches initial set in approximately 1 hour under normal conditions, hardens and final set in approximately 6 to 12 hours. Before the initial set, concrete must be placed in forms vibrated to consolidate its own into formwork. Ensure complete coverage of all reinforcement bars. Finish operations. Such smooth throughout finishes must be performed between initial and final set. Every final set, concrete must be pressed detected with a shock. Extreme temperature change with premature drying until the cure is insufficient hardness. Concrete will be self-supportive in a few days and attain most of the potential strength of 28 days moist curing. For further information, Concrete Use Builders 3 and 2, Volume 1, NAVEDTRA 14250, Concrete Strength. Stated previously, the strength of the concrete determined the water-cement ratio with the strength of the readily mixed concrete ranges from 1,500 to 5,000 pounds per square inch. With further attention of the blade portion, it can get even higher under unusual construction process. The lower strength of the concrete will be given the footers and walls higher than the strength of the beams and columns. Floors require the strength of the concrete given the project to be found. Project plan specification for the specific job. Note, quality control is important to ensure the specific design requirements are met. If the design specification does not meet minimum standards, structural integrity, compromising the structure is considered unsafe with the relief and compressive strength of the concrete chalked on all projects. Strength of the concrete is checked by the cylindrical molds with a 6-inch diameter and 12-inch in height. The concrete samples must be taken on the job site from the concrete that has been placed after being cured a time period that ranges between 7 to 28 days. Cylindrical is broken into the failure laboratory crushing machine measures the force required in the concrete to fail. Further information on the concrete strength testing refer to Engineering Aid 3 and Navy Fac MO 330. Purpose and type of reinforcing steel. Reinforcement concrete was designed with the principle to deal with the concrete active with together resisting force. The concrete is strong with the compression but weak in tension. Tensile strength is generally rated about 10% of the compression strength. For the reason concrete works well is common in post of the arc compression member in a structure, but when it usually tension members such as the berms and girders, foundation walls, and floors, concrete must be reinforced to attain necessary tension and strength. Steel is the best material for the reinforcing concrete, but because of the property of the expansion of the bowl. Steel within concrete considered approximately the same under the normal conditions. Expand with the concrete almost equal rate. No, at a very high temperature, the steel will expand rapidly with the concrete. Two materials will separate. Any reason steel work as well with the reinforced concrete, but because of the bonds well with the concrete, the bond strength with the proportional contracts are for steel with the concrete, in other words, greater than the surface of the steel exposed with the adherence of the concrete strong with the bond that they form. Reinforcing it adheres better with the plain, round, square one because it's greater bearing surface. In fact, where plain bars the same diameter are used instead of deformed bars, approximately 40% more bars must be used. Alright, rougher surfer the steel bars better with adherence to the concrete steel head with a lighter firm layer of the rust appear with the clean steel. However, the steel with loose scale rust is inferior. Loose scale rust can be removed from steel with rubbing the steel with a burlap or similar material. The action leaves down on the firm layer of the runs of steel that adhere with the concrete. Note, the reinforcing steel must be strong with the tension at the same time, ductile enough to shape and bend the cold. Reinforcement steel can be either formed in a bar of the rods, either plain or deformed in the form of expanded with metal, wire, fabric, sheet metal. Each type is used with a different purpose for the engineered design structure with a purpose in mind. Play round bars in cross section. They are used with concrete serves special purposes such as valves, expansion joint with wheel bars, most light in metal or paper sleeve with the contracting joints and roads, runways, and column spirals. They are but least used with the broad type of the reinforcement cover. The other offer only smooth and even surface the bonding of the concrete. Deformed bars differ from the plain bars when they have either indentations in them, ridges on them, or both in regular pattern. Twisted bar with examples made of the twisting of plain square bar, cold, the splitters, or ridges along the surface of the deformed increase the bond strength with the concrete. Other forms are either the round, square, corrugated bars. The bars are formed projections around the surface, extend the surface of the surrounding core, prevent slippage. Another type of it is formed with longitudinal fins protection of the surface to prevent twisting. Figure 7.1 shows a few of the types of deformed bars available in the United States. Deformed barments almost exclusively, while in Europe both deformed and plain bars are used. 7.1 shows various types of deformed bars. 11. Standard size of the reinforcing bars for the table. 7.2. Ends of the bar number to the square with an inches weight and nominal diameter. 11. Standard size bar number 3 through 11 and 14 and 18 are all deformed bars. Figure 7.2 listed for the bars are in square inches, millimeter weight, and pounds per foot, as well as kilograms per meter. The nominal diameter of the 8 is standard metric size. Various sites overseas the rebar can be procured locally and could be metric. Fable 7.3 is given the comparison. Remember, the bar numbers are based on the nearest number of the 1/8 inch included with the nominal diameter of the bar. To measure rebar, you must measure across the round square portion. Whether there is no deformation, raised portion of the deformation is not measured when measuring the rebar. Figure table 7.1 using standard reinforcing bars, bar size designation, area in square inches, weight pound per foot, diameter inches and millimeters. 7.2 metric reinforcing bars, metric reinforcing steel bars, bar size designation, area square inches, square millimeters, weight pound per foot, kilograms per meter, diameter in inches and millimeters. Table 7.3 comparison U.S. customer to metric rebar, U.S. standard bar size, area square inches, metric bar size, area square inches, metric bars is. Hard reinforcing bars are hot rolled variety of steels, several different strength and grades. Most of the reinforced bars are rolled with new steel billets, but there are some of the rolled with the railroad cart used railroad cart axles. Railroad rails have been cut in rollable shapes, assortment, and strength are available. American Society Testing Material has established standard branding of the deformed reinforcing bars. The two general system and the hard bar branding of both systems are the basic purpose of identifying marker size type of steel with the grade. Each bar of the both system identify the mark denoting type of steel is branded on every bar with engraved the final roll used to produce the bars, so the leave with the raised symbols between the deformation manufacturer identity mark that signifies mill rolled bars, usually in single letter or in some cases symbol. Bar size followed the manufacturer mark followed by a symbol indicating new billet steel and a rolled rail steel I. Rolled axle steel A show the 2-grade marking system. Figure 7.2. The lower the strength reinforcement bars show only 3 marks. The initial representation produced with the mill bar side the type of the steel with the high strength. The reinforcement bars, even the continuous line system, the number system show the grade marks in the line system. 1 continuous line rolled into 60,000 psi bars. 2 continuous lines are rolled into 75,000 psi bars. Lines must run at least 5 deformation spaces, shown in figure 7.2. In the number system, 60 is rolled into the following form of steel type mark denoted 60,000 pounds psi. 75 is rolled into 75,000 psi bars. Expand metal and wire mesh reinforcement. Expand metal and wire mesh is used with the reinforced concrete. Expanded metal is made with a partially shearing sheet of metal shown in view A, figure 7.3. Sheet metal has been sheared in a parallel. Lines then pulled out, expanded from the diamond shape between each of the parallel cut and type of the square of the rather than the diamond shape shown in figure 7.3. Expanded metal, customary used during plastic operation, light reinforcing construction, concrete such as sidewalks and small. So, 7 of the 2 show the diamond mesh reinforcement. Concrete pads do not have a substantial weight with its transform air conditioner pads. Welded wire fabric. Welded wire fabric fabricated to form series of the wires are arranged with the right angle with each of the electrical weld at the intersection weld of the wire fabric will form. 2 is WWF within the Navy construction force have the various reinforced construction, concrete construction, building construction, most often use the floor slabs. Well, compacted ground heavy the fabric supplied mainly flat sheets, often use the wells for the primary reinforcement structural floors. Additional examples will include road, runway, pavement, box culverts, small canal linings. 4 numbers used to designate the style of the wire mesh. Examples are 6 by 6 by 6 8 by 8, sometimes written as 6 by 6 by 8 by 8 by or 6 by 6 by width of 2.1 2.1. These first number, in this case 6, indicates the length of the spacing of the wire inches. Second number indicates, in this case, indicated the crosswise spacing of the wire in inches. The last 2 numbers, 8 and 8 by 8, indicate the size of the wire, wash, burn, mow, and gauge. Most recently, the last 2 numbers, the W number indicates the size of the cross-sectional area in width of 100ths of an inch. WWF is currently available with the Navy stock system using 4-digit system 6 by 6 by 8 by 8 as the writing, but procured with the civil source of the W is used. 7.4 shows common stock size of welded wire fabric. Current designation W number. Previous designation was steel wire number. Weight approximate per 100 square feet. Panels and sheets. Rolls. Light fabrication can be supplied with either rolls or flat sheets. The fabric made with the wire heavier than W4 should always be furnished on flat sheets. WWF must uniformly flat when placed in fabric furnished, and the rolls should not be fabricated with a wire heavier than W29. Fabricated furnished rolled fabric complete rolls. Only stock rolls will contain between 7,000 and 1,500 square feet to determine the fabric of the producing location. The unit weight of the WWF is designated pounds per 100 square feet of fabric. 5 feet, 6 feet, 7 feet, 8 and 7 feet 6 inches are standard widths available for the rolls. Standard panel width lengths in 7 feet and 20 feet and 7 feet 6 inches by 20 feet. Sheet metal reinforcement. Sheet metal reinforcement, usually mainly floor, slabs, or stair roof construction, consists of annealed sheet metal bent into the grooves and corrugations about 1/16 of an inch with the holes punched in regular intendeds. Alright, tension and steel. Steel bars are strong in tension, structural grade, capable of safely carrying up to 18,000 pounds from intermediate hard rail steel, 20,000 pounds. This safe from working stress, the braking stress is about triple this. When the model steel bars pull with the testing machine, stretches a very small amount, with each incremental load of the lighter loads of stretching directly proportional amount of the load. Figure 7.4 view A, the amount is too small of the visible can be measured only with a sensitive gauge at some point, but now usually the point in such a 33,000 pounds mild steel bar begins as neck down. Figure 7.4 view B continues to stretch precipitatively with no additional load. Show the figure 7.4 show the tension in steel bars, view A, view B, view C. When it seems the bar is snapped like a rubber band and recover strength due to work hard and additional pull is required, figure 7.4 view C with the produced additional strength of the final failure known as ultimate strength is about 55,000 psi mild strength. Mild steel. Bending reinforcement bars, job bending reinforcement bars, interested in understanding the bending and necessary for the several masons. Let's go back to the reason you the reinforcement steel concrete, tensile strength, compressive strength of the concrete must compare with a hidden action with the beam, live or dead loads and breaking piece of the wood with your knee. You have the splinters next to you with the knee push from the toe of the bindle over the piece of wood when you apply your force on the splinters from mild opposite side pull up and away with the middle and similar to what happens inside of the beam. For instance, if it takes simple beam with the beam resting freely with the two support with the nearest end with the dead load, weight in of the beam cause the beam to bend or sag. Now the center of the beam to the bottom of the forced end of the stress length in the bottom of the portion of the beam. The pad is said to be in tension and that they where the steel reinforcement bars are needed. Resulting in the combination concrete and street with the tensile strength of the beam resists the forced load to keep the beam from the breaking apart. At the exact center of the beam between the compressive stress, tensile strength, there is no stress at all in the neutral. In this case, the continuous bend is a little different with the top beam. Maybe the compression along the part of the length of the tension along the nub of the part of the best cover that continue with the beam. Rest of the more of the two support with the bending of the beam is not all in one direction, reverse, and goes over the intermediate support. To help concrete resist the stress, engineers design bending reinforcement steel with the tail steel that set into the concrete just before the tensile stress taking place for the region. They may have the bending something reinforcement rods almost zigzag pattern joining each member of the next, anchoring the wire ends of the concrete, the anchoring by overlapping two bar ends together. Some of the important ways to increase the keep bond strength. Some of the bends you will be required to make in reinforcing bars shown in Figure 7.5. The drawings or job provided and all information necessary for the cutting and bending of the reinforcement bars. Reinforcement steel can be cut in size of the shear with the oxy-gas cutting torch. The cutting torch can be used in the field before bending of the reinforcement bars. Use the check set forth at the job site. Only after the check bars can you ensure that you all have the needed job. For following construction drawings, when you sort the balls, they will be in proper order to be bent and placed in concrete form. After you've placed the different sizes of piles and labels each pile, so that your crew can find them easily. For the job, bending and number types of the bends will be easy for the stir-ups of the column types of the normal less than number 4, and you can bend them. Alright, typical reinforcement bends. There's a lot of them. Alright, 7.6 shows a bar bending table. Cold mean with the bending table shown in Figure 7.6, the type of stirrup tie shapes shown in Figure 7.7, and stirrups used in beams shown in Figure 7.8, column times shown in position 7.9, and bars of the bent into place bending with a tool like one shown in Figure 7.10, and effectively by placing the jaws and hickey one side and of the hickey on one side of the center of the bend, pulling with a handle will produce smooth and circular bend with an almost angle with the desired bending guides and techniques. Make a bend except for those hooks around pins of the diameter not less than 6 times of the bar, number 3 or number 8, if the bar is larger. Figure 7.7 shows stirrups for the column and ties. 7.8 shows steel beam placement. You have your stirrups, lunge heel reinforcement, beam baluster. The 1-inch column, or number 9, number 10, number 11, the bar minimum diameter has 8 times of the bar size, number 14, number 18, pin diameter shows the 10 times the diameter of the bar. You get smooth, sharp bends with the bending large rod. Slip the pipe of the cheater over the rod. This piece of pipe gives you a better hold on the rod itself that makes the whole operation smoother. You can now heat number 9 bars larger than cherry red before bending them to make sure you don't get them any hotter. If the steel becomes too hot, it will lose strength and become brittle and can even crack. Alright, 7.9 shows column steels in place. 7.10 shows a bending tool. Bend diameters. If you don't want your rod to crack while it's being bent, bend it gradually, not with a jerk. Also, do not make bends too sharp. Bends made on a bar bending table blocks are usually too sharp and the bars are somewhat weakened. Therefore, certain minimum bend diameters have been set with a different bar size, the various types of hooks. The bending details shown in Figure 7.11 use many different types of bendings. One of the selected depends on where you would place the rods. For example, the bends are heavy beam and the girder bars have the reinforcement vertical columns near the floor levels. Bends the stirrup the column ties, bends of the slab reinforcement bends far as wire column spice power reinforcement to save yourself some time, extra work. Try to make all bends of one kind at one time instead of measuring, retesting, setting the templates of the bending block of different bends. Alright, standard hook details, stirrup hooks. Alright, Iron Master Portable Hydraulic Rod Bender Shear. The Iron Master Portable Hydraulic Rod Bender Shear 712 cold work reinforcement bars, various shape of the concrete construction work machines capable of working reinforcement bars up to including number 11 the bars, which are equivalent cross-section area of 1 1/4 inch square and 1 1/2 inch round bar. In addition, all sizes of the reinforcement bars, Iron Master, all work bars, higher carbon content, desired fabrication, anchor bolts, so forth. However, the limitations must be imposed. Consider bar 1 1-inch bar with a diameter greater than the carbon size content greater than 0.18%. So the Society of American Engineers 1020 Coles finished steel bars are under 1 inch in the diameter should have the carbon content no greater than 0.37%, such as the standard American Engineer 1040 CF steel. Although the Iron Master is powered to work steels of heavier sections than 1 1/2 inches, reinforcement manufacturers must place safety limitations whether considering various alloy shapes of steels Users undoubtedly adapt the versatile machine to perform work on other common bar bending, such as bending flats, angles. However, the primary intent of the manufacturer was to produce a machine for bending concrete, reinforcing steel. The manufacturer recommends the Iron Master not be the steels heavier than 1¼ inch square, 1½ inch round reinforcing bars. 712 shows your reinforcing portable hydraulic bender and shear. Standard hook bending. Standard hook bending, figure 713, accomplished with the turntable section located at the top of the machine. Before you start with any of the bending, the turntable must be in the start position shown in 714. Example of where you decide to bend with a 180-degree hook, bend number 11, the reinforcing ball, 7 of the machine shown with you with the following bending cleat with the cleat side with the driving pile. Pin, main center pin, the number 11, the radius roll, as safeguarded radius rolls have been designed to. It shows Iron Master bending unit. Figure 714, example of bending a 100-degree hook with a number 11 rebar. Except only the number of the bar specify the number of 7 roll, the number 7 bar rules. Figure 715, one plain rebar between the clear slide upright with the radius roll placed over the center pin. You have the number 11 radius roll for the 11 bar capacity at 1 bar. 7 radius bar for the 7 bar capacity at 2 bars. 4 radius rolls of 4 bar capacity of 4 bars, radius roller, bending rebar on Iron Master. With the end of the rebar protruding sufficient distance for the cleat side of the upper right, engaging with the wand to the bend meet the cleat side of the contact rebar with the tighten, locking screw with the move of the position, slide bar unfill the roller contacts rebar and tightens with the T-handle. 4. Set the desired angle of the bend of the graduated control bond of the under the right side of the working table, done with the placing of the trigger pin with the rear of the adjustable, stop with the toe of the rear of the machine, end with the hole of the corresponding with the angle of the bend. In this case, it's 180 degrees. This rod is graduated 5 degrees with 190 degrees, 5 degree intervals. Note, ensure the front adjustable, the top trigger pin is in the O hole, so the turntable to return with the top of the start position, retracted after the bend. 5. Advance the engine throttle operating speed of the move with either the rear bending with the control lever and the slide bending covered and control lever bending position. Actuate the bending seal of the lever will stay in bending position until the bend is complete. With the rack movement, it disengage the cylinder with the levers will return to the neutral automatically. To remove the rebar machine after the bend is complete, apply the light intermittent reverse pressure of the lever under the bar, release of the radius roll after the removal of the hook of the machine. Move the lever to the position shown with the retract to return the turntable to the starting position. Figure 75 shows single operation multi-bending number bar size, the number of bars that can be bent in one operation. Okay, multiple bending is accomplished in the same way as standard hook bending of the bars with the number 8, simply placing bars on the machine and one on top of the other. Table 75 shows the bars that may be bent on the Iron Master, the number of the bars that will bend in one operation. On the side of the multiple machine next to the shear with the supporting figure 716 supports hold the bar square between shear blades, prevents them from kicking up during the shearing. The upper jaw of the shearing support is adjustable for the bars 3/4 of an inch. Smaller place the jaw in the lower position for the larger bars, upper position near the shear without using the support. To operate the insert will be cut farthest for the point possible to over the inside of the blades, making sure the blades are in fully opening and retract position. With lightly downward pressure, shear with the control lever with the whole of the bar in position until the shear grips. Continue with applying the pressure downward full limit of the lever until the bar is sheared to retract. The shears pull the lever up. Same size bar that can be bent and sheared with multiple shearing. However, they accomplish only when the bars are less than 4/44 of the square inch area. When the shears more than 1 bar at a time, always place the bars side by side in the shear. A shear with the bars piled on top of each other, otherwise may cause blade failure. Alright, table 716 show the Iron Master bar cutting unit. Table 76 show the number of bars that can be sheared at one time. The care and maintenance of the Iron Master portable hydraulic rod bearing shear consists of the primary lubrication, cleaning the grease with the fittings of the machine. Keep the points well lubricated with a good grease. Grade of grease. Do not over lubricate. Surplus grease will correct the dirt and raw scale with the rebar greasing. The shear pin works shear arm up and down until the grease appears between the arm and side ears. When using stir up the bending attachment, keep the center pin with the lubricated rusting scale from the rebar. Accumulate with the holes and of the turntable, the work table, the serration bending cleat with the roller side. Keep it clean without a particular when changing over the form. Stir up bending attachment, changing center pin with the means of solvent and soaked rag or brush. Keep the work table as clean as possible. Minimize the amount of brush scale dropping from the rack of the gear. Placing and tying reinforcing steel. Before you play with the reinforcing steel in the forms, all oil should be clean. Oil over the reinforcing Bars should be avoided because of the reduce the bond between the bars with the concrete. Use piece of the burlap to remove the rust, smell, scale with the grease, mud, other foreign materials from the bar. All the light film, rust, smell, scale with the objectionable bars are marked to show that they will fit with the may work according with either one of the two must be with the marking members. However, the system should be agreed with the marking system appear with the engineering or assembly drawing. Two marking systems are as follows. All bars, one type of the member, given the mark of the member. The system is used with the column bars, beam bars, footing bars, and so on. Two bars that are marked with greater detail. These marks will show exactly where the bar is placed. In addition, with the top of the member, that is a beam B, wall W, C, column, and so on. The marks show the floor with which the bars are placed inside the individual number to each of the particular player bar. Instead of showing the bar size, diameter, measurement of the mark, show the bar size of the code by eighths. Examples shown below show the second type of the marking system. 2B80F, second floor beam bar, 8 by 8 by 1 inch square bar. 05, part of the second floor plan designated by the number 5. 2B0605, second floor beam bar, 6 to 8, 3/4 inch round bar. 05, part second floor plan designation number 5. To wire you to hold the rebar in place to ensure that when the concrete is placed on the bar, do not shift the position. 16 gauge wire is used to tie. Reinforcing bar, about 12 pounds of wire is required. The average time of the bars. Note the tie to wire adds nothing to the strength of the steel. The number of the different type of the ties can be used with the reinforcement bar. Some of the most effective, other than some types ties have been identified below. According to the letters of the alphabet of the individual ties, snap ties, and simple tie. Wire simply wrap around once around the two crossing bar with a digital manner with the two ends of the twist together with a pair of slide cutters until they are very tight against the bars. Then loose the ends of the wire, cut off 3 times, usually mostly on the floor slabs. B wall top of the tie is made with the going again 1.5 times around the vertical wall diagonally around the intersection, twisting 2 ends together until the connection is tight without breaking the wire or the cutting off the excess. The wall tie is used with vertical mats steel. D, double strand single tie. The tie is variation simple tie, especially favored for heavy work. D, saddle tie. Wires pass halfway around 1.5 bar and 1 band over the either side of the crossing bar with the bar squarely directly and diagonally around the crossing bar with the ends twisted together and cut off. The tie is used in special occasions such as the bar. E, saddle with a tie with a twist of the tie. Variation saddle type of the tie will carry the complete with one over the bar squares across the halfway other the either side of the crossing bar. Finally brought together, twisted either squarely diagonally across saddle tie with a twist. Use heavy masts that are lifted by a crane. F cross figure 8 tie. This type of tie is advantage causing little or no twist in the bars. Proper location reinforcement bars usually given in table 7.7. Order for the structural of the withstand and the loads. It must carry place with steel position. Secure the position in such a way that the concrete placing will not move them. This is accomplished by using the reinforcing bars shown in figure 7.18, 7.19, 17.20. Alright, 7.17 skip ties, 6 types ties. You have a double stranded single tie, cross or figure 8. A saddle tie with a twist, a wall tie, a snap or simple tie, and a saddle tie. Shows a high chair, 8C, a continuous high chair, a saddle baluster, a beam baluster, and that's reinforcement bars, accessories. Proper coverage of the bars, concrete, very important. Protect the bars from fire hazard, possibility, corrosion, explosion of the weather. But not specified minimum standards given below. Figure 7.21 should be observed. 43 inches of the side wall with the concrete against the earth over the bottom of the footings. Other principal structural members where concrete is deposited into the ground. 7.19 shows precast concrete used in the rebar support. You have a tie wire precast concrete, a method of using the concrete blocking. Walls 2 inches from bars larger than number 5, where concrete surface to remove the forms would be exposed to the weather in contact with the ground. 1.5 inch for the number 5 bars, smaller than 3/4 inch for the face of all the walls not exposed directly to the ground or weather. Columns 1.5 inches over spiral ties. Beam the girders 1.5 inch for the nearest bar of the top of the bottom sides. Joints and slabs 3/4 inch for the top bottom sides of the joists on the top and the end of the bottom of the slabs where the concrete surface is not exposed directly to the ground or weather. No, all measurements are from outside of the bar face of the concrete, not from the main steel unless otherwise specified. Footings, other principal structural members against the ground shall have at least 3 inches of the concrete between the steel and the ground. Concrete so for the contact with the ground exposed to the weather. For the removal of forms protecting covering concrete over the steel should be 2 inches. Favoring reduced 1.5 inches for beams or column, 3/4 inch for slabs. Interior wall thickness it should be 2 inches from the exterior wall strip. This measurement is taken from main rebar, not from the stirrups of the ties. Note, whether splicing reinforcement or not, dimension for the drawing of the bars should be lapped not less than 30 times for the bar diameter nor less than 12 inches. Figure 7 shows the trusses of the tension bar. 720 shows the rebar hung in place. Remove these wire before concrete sets. Tie wires, wood strips. Figure 7 shows the length or lap side of the reinforcement, number of the diameter and size of the bars from 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, and 18. Alright, shows the footings, the columns, the walls, the beams, and the slabs and the joists. Can be transmitted through the concrete into the adjoining bar with lap splice for the pieces proper length. For lap of the wire, fabric wire mesh, you can use the number of methods to which for the end of the lap side, lap the end lap method, wire mesh, lap the overlapping one flush, full mesh measured from the end of the longitudinal wires, 1 p to the end of the longitudinal wires, adjacent p, then trying the two piece of the 1 foot 6 inches, something with the snap tie, in the side lap method of the 2 longitudinal side wires placed in one alongside overlapping other. They are tied and snap tied every 3 feet. Reinforcement bars are in the tension, therefore should never be bent around inside corner beam. They are pulled straight through the concrete cover instead. Should overlap extend on the far face of the anchorage 180 degrees. Proper concrete covered bars can also be sliced by metal welding, but only if called for in plan. Specification for the bars placed in vertical position, but is preferred. End of the bottom bar is cut square. End of the top of the resting with its cut with a bevel finishing pre-permitting butt weld for the bears. The weld bear load of the horizontal position. Fillet weld is preferred. Usually 2 bars will be placed at the end of the end rather than overlapping. Place the flat bars with the angle iron and placed on either side. Fillet welds are then made with the metal joints. Figure 722 shows bars spliced with lapping at least 3 bars in diameter. 723 shows the correct and incorrect of the reinforcement inside corner. Shows the correct and incorrect. These welds are made at a depth of 1/2 of the diameter of the length of the 8 times of the diameter, minimum of the clear distance between parallel bars, footing welds, floor slabs, either 1 inch or 1 and 3 times the largest side of the aggregated particle concrete without distance. Engrave the column's clear distance between parallel bars shall not be less than 1.5 times the bar of the diameter, 1.5 times the maximum size of the course aggregated, always with larger 2. To support the reinforcing steel with the 4 slabs, the shown figure 724 with the height over the slab and bolster to determine the required concrete protective cover of the concrete blocks made of sand, cement, mortar can be used in place of sand slab bolsters. Wooden blocks should be never used for this purpose. High chairs can be detained the height up to 6 inches high or greater than 6 inches if required. To make chair out of the number 0 solid annealed iron wire to hold bars firmly into position. You should tie bars together with the frequent intervals when they cross and snap it. Steel column ties are assembled with the vertical cages of the vertical bars from one side of the horizontal and across a couple of saw horses. Proper number of the ties are slipped over the bars. Remaining vertical bars are added, and then the ties are spaced out required by placing plans and all intersections wire together. Placed within assemble the bridge of the beam, hoisted and set as unit. Figure 725 show the typical column tie assembly. After columns are able to tie the dowel of the reinforcement steel with carried up below the hold firmly in position. Base of the column form is erected with the reinforcement style as tie is the column form of 5 foot intervals shown in figure 726. The use of metal supports hold of the reinforcement steel position figure 7 and 8. Note the position of the beam bolster stirrups. Leave the tie of main reinforcement steel with stands. Whenever possible, should assemble the stirrup of the main reinforcement steel outside of the form. Place assembled. Use the position precast concrete block shown in figure 727. May be substituted for metal support. Horizontal vertical boards are widely secured with either or each other sufficiently. Frequently intervals made by a rigid mat. Tying is required at every second or third intersection depending on the size of the spacing of the bars. Not less than 3 ties within 1 bar. In any case, no more than 4 to 6 feet in either direction. So we have a high chair and a side slab bolster. 727, figure 724 steel place and floor slab. Alright, figure 727, 25 shows the column assembly and it shows the ties. And then 726 method of holding a column steel and plane, tie wire. 727 steel place and footing, precast concrete block or stone proper size. Figure 728, steel placed in wall form. We have the formwork, the wood block, the tie wire, the reinforcing bars, the wire, the tile, the dowel, the wall steel. Steel placed in the wall shown in figure 728. The wood block is removed from the form, has been filled with up level of block. Wire wall ties between the top and the bottom should be used. Steel placed and the footings very much in place for slabs. Storage rather than steel support may be used to support steel in proper distance above the subgrade. Steel mats and all small fittings generally preassembled and placed after the forms have been set with the typical arrangement shown in figure 727. The steel mats, the large fittings are constructed in place. Chapter 8, Pre-engineering structural buildings, K-span towers, and antennas.